Hi everyone. In this video, I will be giving a demonstration of confirmatory factor analysis using the Jamovi program. Jamovi is an open source software that you can download at the link that you see on your screen. Basically, it is a shell for the R program where you can easily specify your model using their interface and then observe changes in output appear in real time. So whereas the R program to generate output requires the use of syntax, you're not going to have to use syntax with the Jamovi program. Instead, you're just basically specifying through their interface and you get your output. So it's actually quite easy to use. So in this video, I'm going to demonstrate two approaches for carrying out confirmatory factor analysis using Jamovi. The first approach is a little bit easier than the second approach, but it also contains fewer available options. So I'm just kind of showing you both approaches just kind of to give you a larger lay of the land when you're using Jamovi. So before I get started, I do want to mention that underneath the video description, you'll find a link to the data file that I'll be working from in this presentation. So you can download a copy of the data to follow along. You'll also find a link to a PowerPoint that is going to provide a lot more detail in terms of interpretation and so forth that I'm going to be talking about in this video. So the main objective in this video is to give you sort of a walkthrough of the interface and how to specify your model. I'll talk a little bit about interpretation, but I'm going to leave most of the heavier discussion on interpretation to that PowerPoint. So be sure to download that to learn more. And briefly, I do want to mention that our example, the data for our example is, and the example itself is loosely based off of this study right here. The data is actually part of the complete data set that's provided by these authors who are studying a Spanish language version of the epistemic belief inventory. So basically these authors administered the epistemic belief inventory to Chilean high school students. Their data set actually contains two subsamples. We're going to be working with the second subsample. During their analysis, they basically found a three-factor model was the best fit to the data. We're not going to be replicating their CFA analyses directly. We're actually going to be using just a subset of the items in order to test a three-factor model. And so that particular factor model is based off of a previous presentation that I have put together on exploratory factor analysis with SPSS. So in that previous presentation, I used sample one from this demonstration and generated the factor model. And so we're testing that out using Jamovi here. So just so you know, I'll include a link to this article underneath the video description, and I'll also include a link to that other presentation as well in case you want to learn more about that. Okay, so here I've opened up the Jamovi program. This is the basic interface. And what we need to do is to import our data. So the data file that I'm going to import is an SPSS data file. Just so you know, though, Jamovi does not only import SPSS data. You can also import Excel, CSV files. I believe they can import Stata, SAS, and so forth. But all you need to do is go over here to the left, and if you click on open, you can find your file on your computer. I'm actually going to open up the data down here. This is a recent file. This is an SPSS file right there. So I'll click on that, and you can see that the data has now been imported. So each row in the data set, there's 746 rows. Each row represents a different student. And the columns are representing, by and large, they're the items associated with the EBI. And so as you scroll across, there are some additional variables in here, but we're not going to be using those. So we're only going to be carrying out our analysis using these different items. You can see that you can kind of scroll across a little bit if you want more information about the individual items. You can double click on an item and you got the variable name, measure type. You can even change that if you want, and so forth. So I'm going to click out of that just by clicking the little arrow, the upward arrow, hide. And we'll go ahead and get started running our analysis. And also, before I get started, I do want to mention too that I'll include a link to, I know that I mentioned that I imported the data from SPSS. If you're not an SPSS user and you still want to be able to use this and have a demonstration, I also will include a link to an Excel file underneath the video description as well. So you can download that if you want to start from there. So to get started, we'll click on this factor button at the top. You can see you've got options for reliability, principal components, exploratory factor analysis, and confirmatory factor analysis. So we're going to select confirmatory factor analysis, and our interface opens up. And you can see with our interface that on the left over here, you've got the measured variables in our data set. And then on the right here, you've got, it says factors. This is where we're going to specify our factors for our factor model, and then also associate those factors with their respective indicators. So all we need to do at this point is to first give our factors names. So to do that, what we'll do is we're going to go up here where it says factors. I'm going to click in this box, and there are actually 3 factors that we are going to specify that's associated with this EBI. And the factors are going to be belief in fixed ability and quick learning, the belief in omniscient authority, and belief in that knowledge is simple and certain. So for the first factor, we're going to type in fixed AB period quick, and then press enter. Then we'll add a new factor, and we'll type in OMN period, and then authority, enter, and then add a new factor, and then we'll type in simple period certain, enter. Then we're going to associate the indicators by basically dragging or selecting and clicking the arrow button, moving them over to the right. So we're going to select fixed ability, quick learning right here. I'm going to select CE3, CE5, CE8, CE9, move them over. And then we'll also add to this factor, we'll add 14, then 15, move those over. Then we'll add 20, and then 24 and 27, move those over. Then we'll move down to omniscient authority. There are only 4 items for that one, so we'll select 4 right there, and then 25 and 26. And then for simple certain, we'll add 1, 2, and then move those over, and then we'll select 11, 17, move those over, and then we'll select item 22 and move it over as well. So you can see that as we make those selections to the right, in the pane on the right, we have various outputs appear. Next, we're going to select residual covariances. Just to show you this, we're not going to maintain this in the main model, but if we wanted to add covariances between the error terms, then all we would need to do is to select the items that we are whose errors we are going to correlate, and then just kind of move them over to the right, the box on the right. So I'm going to select, just for this demonstration, 5 and 14, and we'll click on the arrow. And so basically now we've added an error covariance. We're actually not going to be sticking with this for our demonstration, but I just wanted to show you what that looks like. Next, we'll click under options. So in terms of options, what we have are the missing data method, and also you'll see that says constraints. So briefly, a problem that we oftentimes face in the context of multivariate analysis is the problem of missing data. So when you have particularly when you have large number of cases and large number of variables, there's a pretty decent likelihood that you're going to have missing values on at least some of the variables in your data set. So there are 2 options for dealing with that problem. In Jamovi, you have full information maximum likelihood. That's the default under this particular route. And then you also have listwise deletion right here. Basically, listwise deletion, what it does is any case that has missing data on any of the variables that are being included in your analysis, those cases are removed prior to estimation. The full information maximum likelihood approach, the nice thing about it is that, or one of the nice things about it is that you are less likely to lose, many cases as a result of missing data. Whereas list-wise deletion, you're going to lose cases as a result of just any missing data whatsoever on any of your the variables that are being analyzed. So the default under this route, again, is full information maximum likelihood, but I am going to go ahead and select exclude cases list-wise for this particular demonstration. The other thing to kind of note too is that our data set actually does not contain any missing data. So doesn't really kind of matter in this particular case. So this is what I'm going to stick with for this demonstration. In terms of the constraints, basically what's going on here is that these are options for setting the measurement scale of the latent factors themselves. So the latent variables aren't directly measured, but they're kind of indirectly measured by way of the indicators, basically our variables in our data set. And so there are two options available though for scaling the latent factor. And by the way, if the latent factors had no measurement scale, we would have a model that would not be identified. So the two options are to set the factor variance is equal to 1, or to set the scale factor where the or basically set the measurement scale in relation to an indicator associated with your factor. So the default is to set the factor variance is equal to 1. The more conventional approach is actually to this second approach, which is setting the measurement scale of the latent factor in relation to an indicator. And it's using the first indicator in this particular selection right here. So when you do this, just so you know, you'll see up here in the estimates column, these are the unstandardized factor loadings. So you'll see that by doing this, these loadings right here, the first indicator associated with each factor, they're all fixed to 1. And so you can see right there the superscript is indicating these are fixed parameters. But the remaining estimates are given right here. So all of these loadings are estimated, and they have associated significance tests with them. If we were to select the factor variances option right here, you'll see that in the estimates column, these are loadings relating the standardized factors in relation to the unstandardized indicators, and then in which case all of the loadings can be tested for statistical significance. But like I said, this other option is the more standard approach. Where it says estimates, you've got factor covariances and test statistics selected by default. I'm going to select standardized estimate, and what this is going to produce in our table of factor loadings is this column over here where it says standardized estimates. And basically in a model where the indicators are related, each indicator is related to only a single factor, these would all be considered correlations between the indicators and their respective factors. So those are the standardized estimates that you see right here. So next, what we'll do is we will scroll down to model fit. So it already has several model fit indices selected. We're going to go ahead and select SRMR. There's AIC and BIC right there. And what will appear in our output are those model fit statistics that you see down here. So you got model fit right there. There's the chi-square goodness of fit test. There's the CFI, Comparative Fit Index, TLI, Tucker-Lewis Index, SRMR, Standardized Root Mean Square Residual, RMSEA, which is a root mean square error of approximation. There's the RMSEA 90% confidence interval. There's our AIC and BIC that we selected as well. So in terms of those fit measures, I'll just kind of briefly mention that CFI and TLI values, if they're above 0.90, those are typically indicative of an acceptable fitting model. Values 0.95 or above are typically regarded as indicating kind of more superior or optimal levels of fit. SRMR right here, values that fall between 0 and 0.05 would be considered kind of more good fit. Up to about 0.10, up to about 0.10 would be considered more acceptable, maybe perhaps 0.08 by some. RMSEA right here, values up to about 0.05 would be considered indicating close fit. Up to about 0.08 would be considered acceptable, and values greater than 0.10 are indicating poor fit. So that's just kind of a general breakdown of some of the conventions associated with these indices right here. The chi-square goodness of fit test, this is actually the oldest approach to examining fit. It's basically testing whether the observed variances and covariances among your indicator variables differ significantly from the model implied variance covariance matrix. So basically, when you specify your factor model, it's going to imply a set of relationships among your variables. And so the greater correspondence between those two matrices, the better the fit. And if they were overlapping completely, you would have exact fit. And so what this is testing is discrepancy between the observed covariance matrix and the model implied covariance matrix. And if it's statistically significant, then that's going to indicate a significant deviation from exact fit. So you can see right here with the chi-square test, it is statistically significant. So we would reject the null hypothesis in this case is exact fit. So we would reject the exact fit hypothesis. You can see with the CFI value and the TLI value, both of these are less than kind of what is considered acceptable fit. The SRMR and RMSEA, both of those are actually suggesting, reasonably good fit. So you actually kind of have a mixed bag in terms of the fit of our model, the overall fit of our model. Just kind of to reiterate, kind of going back up here though, and looking at our factor loadings, all of those estimated loadings were positive and statistically significant as we're looking at the estimates and those p-values there. Finally, when we look at the additional output, we can request a path diagram. We can click on this button right here and scroll down, and it generates the path diagram for us. And we can also select the residual correlation matrix. So looking at our path diagram right here, this is just our specification of our model. And you can see that, let's see if I can highlight this. There we go. The circles right here, these are our latent factors. The boxes are the indicators of those latent factors. The double-headed arrows over here are correlations or covariances among the latent factors. The single-headed arrows pointing from the latent factors to the indicators, those are essentially indicating the effects of the latent factors on the indicators. So think about it this way, that we're measuring those latent factors indirectly by virtue of those indicator variables. And so each of those single-headed arrows will have a path coefficient associated with it, or excuse me, a factor loading associated with it. It's not shown in here, but they're in that factor loadings table above. You'll see that the dotted line right here, this is just reflecting the reference variable for each of those factors. That's the loading, that is basically the variables whose loading is fixed to 1. So there you go there. We'll scroll up this table of correlation residuals. Essentially, if you think about a matrix of observed correlations among our variables, model implied correlation matrix, the discrepancy between the two is reflected in this matrix right here. The values that are shown in red, those are larger values, basically greater than 0.10, and this can be useful for identifying potential areas within the model of misspecification where you might perhaps make some modifications to improve the fit of the model. There's also in the additional output down here, it says modification indices. You can go down here and you can see suggestions or possible suggestions for improving the model fit if you wanted to do that. But I'm going to get rid of that. And one last thing too, under factor estimates in this little table right here, you'll see that under the estimates column, we've got where it says fixed stability quick. This is the estimated variance of the latent variable, omniscient authority, estimated variance, simple certain, estimated variance. The remaining values that you see right here and here, these are all estimated covariances, and you can talk about the statistical significance in terms of the relationships between the latent factors. So the relationship, the covariance between fixed stability, quick learning, and omniscient authority is 0.1018, and you can see that that is statistically significant. The relationship between fixed stability, quick learning, and simple certain knowledge is 0.0411, and you can see that that is statistically significant. And then between omniscient authority and simple certain right here, there's the covariance of 0.0801, and you can see that that is statistically significant. When you look at the standardized estimates column right here, these ones right here are basically the variances of the latent variables after standardization. So, but the remaining values that you see right here, these are correlations between each between the latent variables. So, in a nutshell, as you're looking at this, you can see that the correlation between fixed stability and quick learning and omniscient authority is 0.188. The relationship between fixed and quick and the simple certain factor is 0.14. And then the correlation between omniscient authority and simple certain knowledge is 0.222. So there you go. So that's just kind of a quick rundown of using this particular approach to generating our results. So now let's take a look at the second option for generating our confirmatory factor analysis results. To do that, we're going to be using an option under this button right here, but that's not shown. So what we need to do is to make sure that we add a module to this. So I'm going to click on the little modules plus sign right here. And as we're looking at it, there it says Jamovi library. So I'm going to click on Jamovi library and scroll down, and you'll see it says SEM LJ SEM right here, and we're going to click on install. So this module is going to be installed. So I'll click on install, and so now it says module installed. So we'll click out of here, and then when we go up to this button, you'll find there are two options. There's a syntax mode and there's an interactive mode. So I'm going to stick with the interactive mode by clicking on it. And basically the layout is very similar to what we had before, but in this case, this actually will allow you to perform more full-on structural equation modeling, not just have to carry out a CFA, but you can also do a full structural equation model with latent variables. So just think of CFA as essentially a member of the family of structural equation models. So what we're going to do is where it says latent exogenous variables down here, I'm going to give the names of my three factors. So the first factor is going to be the fixed stability quick learning factor right there. Then press enter. Then new latent variable, we'll type in OMN period authority, enter, and then we'll do our simple certain as well. So simple dot certain right there, press enter, and then we'll drag our variables over, or we'll move them over. So here we'll go ahead and select for our fixed ability quick learning factor, we'll select 3, 5, 8, 9, then we have 14, 15, 20. We'll go ahead and move those over here. And then we'll add in the 24 and 27. So we'll move those over here. Then for omniscient authority, we had item 4. Go ahead and move it over. And then we'll do 25 and 26. We'll move them over as well. Then for simple certain, we'll move item 1, 2, 11, 17, and then 22, and we'll move those over there. So now you can see, again, the defaults have kicked in, and so we have a number of different pieces of output that have been generated. So next what we'll do is we can use this little motivator here and kind of go down. And so you can see that where it says variances and covariances, this is where you can specify those correlated errors or the covariances in terms of the residuals, as I showed you previously. So again, if you wanted to add in, let's say, a covariance between just for argument's sake, 4 and item 27, we can select their pairs right there, and that would take care of it. We're going to remove that again and just kind of stick with what we had. Under model options, you'll see the estimation approach method is automatic. I'm going to go ahead and select maximum likelihood, leave the maximum likelihood approach set for automatic right there. You'll notice that down here where it says data, the default was listwise deletion, but you do have some other options, including full information maximum likelihood. So I'm going to stick with this right now with listwise deletion. Just keep in mind, though, that the full information maximum likelihood is really probably a better option in those cases where you have missing data, particularly missing data is missing at random. Okay, so then we've got the parameters option. So you got options for standard errors, you got automatic, standard, and so forth. You even have a bootstrap option there. I'm not going to click on that, but there's an option there for that. For confidence intervals, we can select betas. So previously, when we selected betas, when we went to our factor loadings, we only had the unstandardized factor loadings and we had a significance test, and we could have requested confidence intervals for those unstandardized factor loadings, but we could not have gotten confidence intervals for the standardized factor loadings. So here, though, when we click betas, and you'll see it says confidence levels, then right here in our output, let me just kind of highlight it for you. Over here, try that one more time. Okay, there we go. Right here, you have the standardized factor loadings and 95% confidence intervals for those loadings. So you can actually use these confidence intervals to test the significance of the standardized factor loadings. Whereas over here, you've got the unstandardized factor loadings, and then you've got the significance test given, there's your standard error, Z value, and P value. So you can test those out, or if you wanted to use the confidence intervals for the unstandardized loadings, you could have used that for carrying out the tests. But, in a nutshell, to use the confidence intervals for testing the statistical significance of a factor loading, basically if 0 falls between the lower and the upper bound of the confidence interval, 0 being the null, then the factor loading would not be deemed as statistically significant. Whereas if the factor loading falls outside of that interval, then that would be deemed as statistically significant. So that's just kind of what you can see right here in this table where it says measurement model. And by the way, CFA model is also referred to as a measurement model. So that's what this is right here. So if you ever hear someone refer to testing a measurement model, that's what they're doing. They're basically doing a CFA. In terms of some of the other options down here, we're going to actually click off of mean structure. We're just kind of keeping things simple. And then down here where it says standardized variables, you'll notice that by default, it is set up for latent variables, fixed first indicator to 1. So that's consistent with what we had utilized previously. If we click on output options, you can see that we've got options for additional fit measures. There's Martius coefficients if you want to test for multivariate normality. Not a bad idea, by the way. And then, in fact, the basic maximum likelihood estimation makes the assumption of multivariate normality. So having that information would be very useful in making that determination as to whether we should stick with maximum likelihood or a robust maximum likelihood or some other approach. And I will mention too, I'll kind of scroll up here under the method of estimation. Unlike the other route that we went through, where it says method, you've got options for robust maximum likelihood. The one I typically use is the robust maximum likelihood, MLR, which is going to be particularly useful in those cases where you have missing data. So just kind of an FYI there for you. So you can also request reliability indices, so you can get Cronbach's alpha, and you can also get the omega coefficient as well for evaluating the reliability of the indicators associated with a given factor. You can also ask for R-square value. I'm going to click on the all down here. The R-square values that are generated, and you can see it's about to come up, these are going to be communality estimates for our indicators. So the communality is basically reflecting the proportion of variation in your indicators, each indicator that's accounted for by the latent factors. And because in our model, each latent factor is associated with a single indicator, this would be the proportion of variation accounted for in each indicator by its respective latent factor. You can also see, there's the modification indices option right there if you wanted to make that selection, and so forth. I'll also mention up here that, and it takes, sometimes when you make different changes, it takes a moment for it to think. So that's why, you can kind of see the little thinking icon moving. All right, so now up here at the top, you'll notice too, just kind of a general description of the model. So as we're looking at this, just kind of highlight this, you can see it says estimation method, maximum likelihood, number of observations, 746, number of free parameters, 37, standard errors, the standard approach to standard errors, and so forth. And then this right here is actually R syntax. Basically, we're using the Lavon, we're pivoting off of R, but we're using the Lavon package and SEM tools package with R in order to generate our results. But this, again, Jamovi is serving as a shell, so we don't actually have to type all this in. But if you want to learn more about how to specify a model using R syntax, this is kind of a nice little demonstration right here. So where it says model, we have the name of our factor right here, then an equal sign followed by a tilde, followed by CE3 plus CE5 plus CE8 plus CE9, 14, 15, all the way through the last set of items right there. So that's specifying which items go with the fixed ability factor. Then you've got the omniscient authority factor, equal sign followed by a tilde, then those items, and then simple certain, equal sign, tilde, and then we've got those items separated by plus signs. So that's just a little FYI there for you. Where it says overall tests, right here you'll see that we've got the user model. This is our chi-square goodness of fit test. So this is the same set of results that we had before. You'll also notice that the fit indices, we have the same ones as before, SRMR, RMSEA. There's our 90% confidence interval. This is actually mislabeled in this current version. It should say 90%, not 95%. And then we have an RMSEA p-value, and this is basically just testing whether our model is significantly different from a close fitting model. And so if this p-value is non-significant, then our model would be considered consistent with a close fitting model. You'll also see some of the other fit statistics that are available. You've got up here, you've got the comparative fit index right here. There's the TLI right there. You'll also see some other indices that are sometimes reported: goodness of fit index, adjusted goodness of fit index. There's McDonald's fit index. So some of these are discussed in the PowerPoint that I was referencing. So we'll move on down. The R-square values, again, these are going to be the communalities in our current associated with each of our indicator variables that you see right here. Down below, our estimates table contains our unstandardized factor loadings. So that's in the estimates column. Again, we had fixed the loading for each of our first indicators on each factor to 1. So those are those values. The remaining loadings are estimated, and then we have test results for those. And if we wanted to test out the significance of the standardized loadings, these are the loadings right here themselves, and then we have the lower and the upper bound of a 95% of the 95% confidence intervals for those loadings. We'll scroll down a little bit further. We've got a table of variances and covariances. So in this table right here, we've got these are the estimated variances associated with each of our basically the residual variances associated with each of our indicator variables. You'll see that we've got down here, we've got the latent variable variance for fixed ability, fixed and quick learning factor, omniscient authority factor, and then simple certain factor right there. And then we have the covariances between our latent factors. So covariances between fixed ability, quick learning, and omniscient authority. There it is. Fixed, quick, and simple certain. There it is. And then omniscient authority, simple certain. There it is. And then again, if we look over here under the standardized estimates, you can see these are basically the correlations between those latent factors, and then you can use the confidence interval that's provided right here in order to test those correlations out if you wanted to report that. Under additional outputs, you can see that we've got our reliability indices. So there's Crumbux alpha. This is the omega value if you wanted to use that. And there's average variance extracted. I discussed these in more detail in the PowerPoint. Then you've got Martius coefficients for testing multivariate normality. So you've got the testing multivariate skew and kurtosis. Both of these are significant, which is actually suggesting that we have significant deviation from normality with our observed variables. Under path diagram at the very bottom, you'll see you can click on that button right there. And in this case, you can also request, in this model that's generated, the default are the coefficients, the unstandardized coefficients that are showing up. And then the double-headed arrows have the covariances among the latent variables. If you want the residuals shown, you can click on this button right here where it says show residuals, and you can get the residual variances showing up. So there they are to the right of the indicator variables. If you click on betas, then this will produce the completely standardized output, which the factor loadings would be the standardized factor loadings, and then the double-headed arrows in this are the correlations between each of the latent variables. And I'll go ahead and show you one other thing. If we go under SEM and then go to SEM Interactive, you end up, excuse me, not interactive, under syntax, this is what you end up with. And you can type that code for your model in the box on the left and make whatever specifications down below. If you click that green arrow, then your analysis will run. So you can actually save that code, and you can bring it into this module right here, or if you can just type in the code, it may be sometimes quicker than trying to use the drag and drop options that I was showing you before. But I'll go ahead and show you just the specification of fixed ability, the fixed AB dot quick factor. We'll set that equal to and a tilde sign. That's reflecting that we're going to be specifying the indicators for this factor. So I'll type in CE3 plus CE5 plus CE8 plus CE9 plus CE14 plus CE15 plus CE20 plus CE24 plus CE27. So we'll go to the next line and we'll type in OMN period authority equal sign followed by a tilde, then CE4 plus CE25 plus CE26. Then we'll go to the next line and we'll type in simple period certain right there. And then we'll type in equals tilde and then CE1 plus CE2 plus CE11 plus CE17 plus CE22. So at this point, we can, obviously we can run it just with the defaults on just by clicking the green button. And so you can see it generates results over here, or you can make those changes like under model options. We can, there's maximum likelihood right there. Missing values is set under parameter options. We can select betas right there. Under output options, we can select, additional fit, indices, Martius coefficients, reliability, R-square values, path diagram. We can select everything that we had selected before when we just ran our model through the interactive mode. So there you go. Okay, so one last thing I want to show you, I'm going to actually go back and I'm going to select a data file that contains missing data. And what I'll do, so you can see that I've actually opened up a new jamovi folder, jamovi interface right here with that data set. And you can see that there's missing values that are contained, in these areas right here. So I just want to show you just kind of what it might look like when you're running your analysis. And I'm just to kind of make my life a little easier, I'm going to steal this information out of here and then go back under the new jamovi here and go back under the syntax mode and put that in here. So in terms of, if you recall under let me see if I can find it here. Under model options, the default for missing values is listwise deletion. If I go ahead and run this, if I click this button right here using listwise deletion, you're going to see that you get a little message down here. It says, note, there are missing values in the data and they are removed listwise. Please consider other methods of handling missing data values that's available under model options. So that is basically suggesting that you use the full information maximum likelihood method in order to run the model. So I'll go ahead and do that. I'm going to select FIML right there, and you can see that warning goes away, and so you have your estimates and everything showing up. The other thing I wanted to show you too is that, and by the way, the automatic right now is still the maximum likelihood. I'll just kind of put it back on that. Remember that we had found that we had some evidence of multivariate non-normality, and maximum likelihood estimation does make the assumption of multivariate normality. When that violation, when that assumption is not met, then it can result in biases in terms of the chi-square test statistic. Oftentimes it becomes inflated, and also biases in terms of the standard errors when you're that's associated with the test of your regression parameters. So what we can do is to select MLR down here as well, and then it's going to generate basically robust fit indices as well as standard errors that are adjusted for more robust standard errors. So if we kind of scroll up to the very top here, you'll see that in terms of the estimation approach, we still got robust maximum likelihood, so we're still estimating with that, but you'll notice it says standard errors. It's got robust Huber and White. The scaled chi-square test value is Jan Bentler chi-square value. You'll see where it says overall test right here, that we've got, this is the original chi-square goodness of fit test that you see right here. The scaled user chi-square, this is a Jan Bentler version of the chi-square goodness of fit test. This is a Jan Bentler test value that you see right there. When we scroll down a little bit further, you can see the fit indices. There are several that are reported. You've got the classical, which is the previous versions of the fit indices. Then you got robust fit indices and scaled. So both these two sets of fit indices. So for there's SRMR, they're actually going to be the same. But for the RMSEA, and then down here you've got the comparative fit index, scaled and robust, TLI, scaled and robust, and so forth. So you can kind of pick, one or the other in terms of reporting your reporting on kind of the robust indices. But I kind of go into this in more detail within the PowerPoint, and I don't want to take up much more time than I've already taken up in this video presentation. So just be sure to check out that PowerPoint where I kind of discuss some of this in a little bit more detail. But there's our estimates table that you see right here. Obviously, we can request those standardized estimates. They're not requested. Oh, yeah, actually, they are. Excuse me. But nevertheless, let me just kind of go back to my options and parameter options. There's our betas, getting the confidence intervals. Yeah, there it is right there. And then I'm going to click off of mean structure. Actually, you can't click off mean structure here because you're using the FIML up here. So that does require having the mean structure clicked. And but anyway, that's just kind of a general overview of some of the additional stuff that I wanted to bring up. As I said, in the PowerPoint, there's a lot more detail than I really could provide efficiently in this video. So I'm going to leave it to that for the rest of it. So that's going to conclude this video presentation, and I appreciate you watching.